In this episode...
Do you want to guess what heat pump they put in? 3-phase, 30 kilowatt carrier.
Yeah, here we go.
Even the guys that really do know what they're doing are still oversizing heat pumps.
Especially the Drayton TRV4, isn't it? That's a hellish thing.
We've chopped off a corner of this bedroom that I'm in.
A heat pump can be the best thing that you ever do for your house. It can very, very easily be the worst thing you ever do for your house as well.
I've always said that accountability should never be seen as our enemy.
Good insulation is going to be better.
We wait until we're cold and then we look for comfort rather than just being comfortable.
So it's also a bit of a trial run.
A buffer or any hydraulic separation should be seen as a last resort.
It's that old saying, if it ain't broke, don't fix it.
Welcome to another episode of Homeowners Q&A. Today we're exploring what homeowners need to consider when switching from a fossil fuel boiler to a heat pump. We'll cover the unique challenges of retrofitting, from evaluating pipework and heat emitters to understanding how this transition affects overall system efficiency. I'm your host Mars, and today I'm joined by an expert panel to guide us through the process and answer any pressing questions. We have Rob and Furze from Good Energy, Rob from Berridge Heating Design Consultants, Patrick Wheeler from Vito Energy, and Barry Sharp from Renewable Heat. Welcome everybody. But before we get started, we'd like to say a huge thank you to today's sponsor, Good Energy. Starting out as a renewable energy supplier 25 years ago, Good Energy has grown to offer heat pump, solar and battery installations, smart energy tariffs and electric vehicle charging solutions. Good Energy is also the only B Corp home energy supplier in the UK, proving their commitment to people and the planet. And quality is also guaranteed because Good Energy only installs premium hardware that's built to last, and that's backed by long-term warranties. And there are no third parties, just directly employed, highly qualified and accredited teams that treat your home with respect. If you'd like to find out more, head over to goodenergy.co.uk. Right, Barry, so let's start with you. Let's ease into the conversation. The first thing we need to cover is, what are the first things that homeowners should evaluate in their homes before switching from a boiler to a low-temperature heating unit like a heat pump?
I flip this question around and ask the client, first of all, why? Like Simon Sinek's book, Start With Why. I think you should be doing a heat pump at certain points of a journey in the house. There's quite a few times you go to someone's house and they've got a 4 or 5 year old gas boiler which has got a bit of life in it. And really, maybe they've done a lot of work in the house already and are thinking about tearing the house upside down to put a heat pump in. Maybe that's not the best time to do it. When I start the conversation with somebody, it's, why are you doing this? What's the point of the house? If you've just bought the house, that's a good point to start the journey of a heat pump. Are you thinking renovations or major work? That's a good point. That should be the first conversation, because you should be looking at this decarbonisation as a journey and not just, that's what I'm doing first. You've got to look at the whole house and what's the best to do at the best time.
So Robin, you do a lot of surveys. What do you typically evaluate when you do go to a home and somebody has got a boiler? What are you looking for to actually make that transition from that boiler to a heat pump more seamless?
Yeah, so I think the first thing we'd look at is the property's existing insulation levels. We'll look at their EPC if they've got one. We'll look at things like what radiator types they already have, or what heating emitters they already have. What's the size of the pipework feeding those? Other things such as window sizes, and basically do an entire heat loss calculation or gather the information to be able to do that.
I think I'd echo exactly what Barry was saying, is that, I truly believe that there's procedure for a reason. And I think if there's any kind of low-hanging fruit that you can get, first of all, on this journey, things like windows, things like door seals, things like, roof insulation, grant monies available for wall insulation, that kind of thing. When you're looking at the average heat losses in the UK between 6 and 8 kilowatts, we need to be a little bit more serious about how we go about these things. I always say that the heat source should be the very, very last decision that you make once you've got everything else. I'm not a complete die-hard fabric first guy. I'm not at all, because I think that you can future-proof, as long as you're doing a reasonable heat loss calculation to a proper industry standard like EN 12831. You can then say, and you can model within the software all of the building improvements you're going to do over time, put in the size of heat pump that you're going to need for that, and then start doing the other works, and maybe run a separate heat source until you've actually done all the works, and then you've got the right size and the maximum efficiency from that unit.
I'm going to add to that, Rob, because you're spot on. I mean, at the start, when we started doing heat pumps 20 years ago, the Swedes were telling us design for 80%, because they were like, you don't need 100%. And we can see that on Open Energy Monitor as well, that even the guys that really do know what they're doing are still oversizing heat pumps.
Yeah, but this is why all the Scandinavian countries, they all seem to size to around 70 to 80%. And then for the 2 or 3 weeks of the year when it does drop down to ODT, they're using a secondary heat source, which actually works out, even if it's a plug-in electric heater. Also, forward thinking, and you're lucky enough to have roof space to put some solar in or some battery storage or something like that, it becomes a complete no-brainer.
I think this has been a knee-jerk reaction, Rob, because we were doing that at the start, but we weren't doing heat losses at the start. Because I remember my first heat pumps, we were just literally going, it must be 50 watts a square metre. And I think this is where it came from. If we're doing it right at the start, we probably could still do 80% because we wouldn't have all these bad heat pumps out there.
And verified monitoring, I think, is important. We know that measuring is better than calculation. Rob, you'll know better than anyone how difficult it is to do an accurate heat loss calculation. Even if you know theoretically what the R values are of everything and you put it all together, it's really, really fallible because you've got to have a good understanding of air change rates. I think in almost all cases, heat losses, even by a really diligent designer, are quite a bit over. So then the fact that we're designing to 100%, like we just discussed, plus the fact that you've only got several outputs of heat pump that you can fit, I think in almost all cases, heat pumps are oversized.
Patrick, you made a good point there. I think that's what's missing in industry is closing that loop between what we say and what we deliver. We don't get people coming back saying, you said a COP of 3.5, but I've only got 3.2. We never have those conversations. Nobody calls accountable for our designs.
One of the things that we have in the MCS paperwork, although it's incredibly fallible, is the performance estimate. And the performance estimate as it stands is a little bit of a nonsense. It's based on some data that doesn't really make any difference. If that was buttoned up a little bit better and it was slightly more accurate and could portray what we as engineers are trying to give to our customers when we're trying to do our best and design it and install it and everything else. If we were then slightly held to it, not necessarily in a way that would disincentivize people that are learning or might not be perfect, but if the customer was told this is pretty much what we think we're going to do, this is pretty much what your energy profile is going to be and what your running costs might be, as long as you run the system in the way that we set it up. If there's then a soft audit later to say it's not really following that, you're quite a bit under or over on energy consumption, would you like to go back and see if you can do a bit better? All of that stuff's already in place. If the performance estimate is more accurate somehow, and we have some kind of verified measurement, some heat pumps are pretty good at measuring it themselves. Some are wildly inaccurate. If the manufacturers are told you've got to be pretty accurate on the measurement of energy usage and your overall efficiencies, we can then measure it against what we said we were going to do. I'd absolutely welcome a little bit more from the regulatory bodies to say, do the job you said you were going to do.
Imagine that conversation going back to a client and saying, oh, we estimated 10,000 kilowatt hours. We're actually 9,000 kilowatt hours. This system's running better than we expected. Imagine that conversation.
I've always said that accountability should never be seen as our enemy. I've actually started to change my mind on quite a lot of things over the last little while that I've been spouting for the last 20 years. As long as you're prepared to kind of, move as the data moves, then that's fine. I always say data is science, and that's it. And this is what we're finding with Heat Pump Monitor. And as we're moving in further in towards winter, for me, it's really revealing some things that the industry as a standard from a modelling and from a calculation perspective has actually got quite wrong. This whole Scandinavian approach of 70 to 80% of heat loss is probably a pretty damn good idea.
Anecdotally, we've got a client, a big London house, very expensive, lovely house. We don't get involved with the actual heat sources. They've got a few heat pumps doing different things. We're doing controls and hydronics and underfloor and stuff. And they had a heat pump replaced the other day. The heat loss total is between 10 and 12 kilowatts, depending on which model we used. Do you want to guess what heat pump they put in? 3-phase 30 kilowatt carrier.
Yeah, here we go.
One of the things I say too often, which is a bit glib maybe, is a heat pump can be the best thing that you ever do for your house. It can very, very easily be the worst thing you ever do for your house as well, depending on who fits it and how diligently it's put in. And we've got relatively wealthy clients that have ended up turning it off because it was installed poorly and it's got billions of pumps that it doesn't need and loads of hydraulic separation on separation. And that can make it incredibly expensive to run. In the end, they turn it off or replace it or find an alternative, refit the boiler or something.
Planning to install an air source heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle. Link in the description. Robin, you're in the process of actually transitioning from a boiler to a heat pump. Could you walk us through some of the challenges that you've actually come across?
Actually transitioned already, so I suppose the biggest challenge for us was location of the heat pump. So it's just a semi-detached property. We actually chose to put it at the front, beneath the front living room window, which is nice. It's out of the way. It's not where we're going to be using the garden particularly. But we've also had to find somewhere to put a cylinder where there wasn't space for a large unvented cylinder. We've chopped off a corner of this bedroom that I'm in, and it will be boxed in once the rest of the renovations start happening. At the moment, there's a lot of visible pipe work, so not quite got there yet. Yeah, generally speaking, the radiators that we had already in were all perfectly suitable for a low temperature design. The only one that we needed to upgrade was the bathroom, but we've renovated that now anyway, so we've already installed a new towel rail that's suitable, and we will eventually eventually put underfloor heating in to reduce that design temperature and increase the efficiency.
It might be worth adding to that point for people that putting in an overlay system and retrofitting underfloor heating after the job is a very, very good option, and to increase your volume. I'm trying to work on the idea now of between sort of 17 and 20 litres per kilowatt as the perfect amount of volume, system water volume that you can have in there, so you get nice long, low and slow heating run times on the heat pump, and obviously produce much better efficiencies and higher coefficients of performance. Have you changed all your radiator valves and everything then as well at this stage or not?
Not at this stage, no.
Rob, are you asking that because of flow? Because of some TRVs and lock shields have got really, really tiny apertures?
Yeah, they do, especially the Drayton TRV4, doesn't it? That's a hellish thing.
What do you recommend then?
With heat pumps, if you're going to use radiators, I'm a big advocate of one-pipe systems where there's no resistance at all. I've always said there's two things that you can't oversize in a heating system. One is radiators and the other one is expansion. It's quite important to get that across to clients that the more system water volume they can get in their system, the better it's going to run. We don't heat on-off these days. The whole idea of heating is long, low and slow. Leave it on, let it do its thing, let the controls do their job and rely on the technology, frankly.
So we use TRVs just as limiters for solar gains or for whatever else. They're there as a backstop, same as underfloor. As long as it's been specified or over-specified for volume, then generally it's pretty good. People don't complain if it's 22 degrees, but they will complain if it's 19.
That's that. Well, not to get too technical for homeowners, as this is that sort of podcast, but it's normally, if you're looking at an index circuit, which for these listeners is basically the most resistance on it, within the circuit that the pump has to get over before it circulates the water around. It's normally a valve. It's not normally the pipework or anything like that. It's normally a valve that is causing it. And so the least amount of valves that you can have, and technically, if you've sized the radiators correctly and you've got good compensation controls, and you've, as Patrick has said, you've managed any solar gain that comes into the building, do you actually need any radiator valves at all? Technically, you don't.
Patrick, in terms of Microbore, what are the challenges with Microbore and heat pumps? I mean, this is something that I keep seeing coming up. Is it genuinely the problem that everybody makes it out to be?
Makes it more complicated, yeah. The main thing that it means for us is that we can't do our normal open loop strategy. So the vast majority of systems we fit have nothing really else in the house that you don't already have. There's a cylinder, a diverter valve, and that's about it, and some controls, and everything else is done from the heat pump. So we don't add mix zones or buffers or low loss headers or loads of extra pumps and valves and stuff that we quite often take out of other people's installs, which is expensive and makes it less efficient. They have to be used for a reason. And the reason for us is things like residual pump head. So if we need more than the pump has got in the heat pump because of resistance in the system, we need to overcome that somehow. And in the case of Microbore, we've got one project this week that we're doing which does have Microbore, and that's got some hydraulic separation. So it's got a 3-pipe buffer to get over that and to make sure that the different circuits can keep their relevant flow rates. And so it's not a barrier, it just means that it needs a bit more forethought.
I'm always a bit cautious. I don't have a problem with 10 mil at all. I'm a bit nervous about 8 because the age of it, because 8 mil's probably 50-year-old and it's probably starting to fur up inside. And plus, when I was fitting Microbore, I wasn't careful putting it in when I started my apprenticeship. There's a good chance it's got kinks that you can't see. That I'm always a bit like, if we can get it out, we will. A bit of caution really, because you don't know what's happened to that system in the past.
Oh, 100%. And if it's the really old stuff that's the copper going back to the manifolds, and those manifolds have been hidden somewhere in an eaves cupboard or under a floor, and it was open vent and now you're pressurizing it or you flushed it and some of the dirt that was sealing that manifold is no longer there, yeah, it's definitely a risk. We've got some pretty clear caveats in our T's and C's. If it doesn't work, you may be in it for some extra pipe work.
Our natural action is just to go and rip everything out, but maybe we should think about your installation as a journey as well, that we try this first, keep disruption to a minimum and be aware that there might be extra radiators, there might be issues with pipe work, and we'll deal with them as and when they come.
I think that brings me on to another really big point we probably are guilty of as well, replacing things that don't need replacing or replacing things that can be made to work. Is there a decent ROI on it, and what's the carbon footprint implication if you're replacing a hot water cylinder that's still got another 15 years of guarantee in it and probably 30 years of life, just so that you can run your heat pump a little bit colder because you've got a bigger heat exchanger? Can we get away with reusing stuff that's already in the house? If you're replacing a boiler that's only a few years old, yes, you're doing the right thing from a point of use emissions, but the full supply chain, the life cycle of that house has got a lot worse by removing something that's still got a decade or two of life in it. Let's not replace things if we can get away with it.
We should be trying to extend the life of current gas boilers until they're ready for a heat pump change. We're too happy in this country to rip the boiler out and put a new one in rather than try and fix it or maintain it.
Install the heat pump alongside the boiler as a hybrid until you've done all of that work, and then you can retire all the gas plant in time.
I used to be quite outspoken against hybrids because I thought I was a bit of a purist. We've got a big problem with small homes with combi boilers in a cupboard or somewhere. You're not going to use that space for much else. You don't need it for the heat pump. If you could fit a heat pump and run it just for the heating, and then you can have the combi available for peak, maybe if we're designing at 80%, and for hot water, so you don't need to find somewhere to put a massive cylinder that's quite a lot of money.
And you're talking about a very, very cheap transition to do that. I mean, most of these heat pumps units now will just tee into the returns of the boiler plant. It's a very, very good solution, which you're probably 80% of the way there throughout the course of the year. And so this is why I say, a transition is not just fall off the cliff and everything just changes over. It's going to take time and it's going to move over time. You can argue the point of how we produce all the electricity, etc., which is going to be required. At this point in time, to my point, is why would you take out something? What's that old saying? If it ain't broke, don't fix it.
Well, we should be clear that the reason that we're taking them out is because at the moment the vast majority of retrofit air source heat pumps are supported by the boiler upgrade scheme, and that specifically says we've got to take the boiler out. It literally is the boiler upgrade scheme. We're removing it. There's a consultation about hybrids at the moment. I'm not sure what the result of that will be, but hopefully there's a bit of pragmatic change coming.
They softened it in Scotland that if you can justify why you're doing it, then they'll let it go through for the funding.
So, Patrick, if I could just go back to an earlier comment, you mentioned buffer tanks and Microbore. If you have got Microbore, you've got no choice to actually fit a buffer just so that you actually can kind of work your way around the actual Microbore. Is that a correct statement? Am I understanding what you said correctly?
A buffer or any hydraulic separation should be seen as a last resort or used for a particular reason. In lots of cases, the manufacturers want them because it helps prove that their system's working because they can see circulation through the heat pump. So if there's a warranty call, they'll be able to more accurately work out which side of it the problem is. The complexity of a heat pump versus the system is quite big. So if the system's good, the heat pump will usually be good. And if the system's a problem, then the heat pump usually doesn't operate correctly. So hydraulic separation is often put in as standard, historically anyway, whereas we tend to engineer it out unless there's a purpose for it. And Microbore is a really good reason for it.
Robin, do you have Microbore in your property?
I've got 15 mil.
Did you fit a buffer tank?
We have, but only because we have a future plan for underfloor heating. So it's not actually a separate buffer tank. Our cylinder has a built-in buffer tank. So it's also a bit of a trial run for that as well.
You can use that as a volumizer later on if you don't get the amount up, which is great.
It's important to say there's never a downside for a volumizer, apart from implementation cost.
Just space. You might get away with a hot water cylinder, but when you start doing expansion vessels and volumizers, then you start to kind of run out of space.
I mean, even though this is an episode about retrofits, I thought this was a really interesting question that I think we might get some interesting answers on. This person has access to a hot spring in their property with a temperature of 45 to 55 degrees centigrade with a flow rate of 4 liters per minute. The hot spring is actually located inside the house and has a tank 300 mils long by 250 mils wide and 300 mils deep into which the spring flows. And they're asking, can this be used with a heat exchanger to heat radiators in various rooms?
Yeah, definitely. Tell them to give me a ring because I'd love to get involved in that. That sounds like a great project.
A nice open loop system, that'd be amazing.
How would that compare kind of price-wise to putting in a heat pump or something like that in terms of that heat exchanger and running that into your home versus actually putting a monoblock or some sort of unit into your property? Is it going to be a lot cheaper comparatively?
Definitely. I mean, there's so many hot water cylinder companies now and heat exchanger companies now that will build you a bespoke unit for whatever you want for a few hundred quid for something like that. I would think you could use it as a thermal store and have multiple coils inside it for whatever you wanted to do.
Still sticking on the retrofit aspect of things, the one argument and issue that a lot of homeowners have got is the actual taxation that still exists on gas versus electricity. Gas is typically taxed at about 0.5p per kilowatt hour, which is 8 times more than electricity. So very roughly, a typical gas boiler pays taxes of about 50 quid a year versus 125 on electricity, while creating 80% less emissions. In your opinions, is this something that needs to be addressed in order to incentivize more people to actually get rid of that boiler and for an air source heat pump in?
It's a big question. If the industry is from a very high level supporting electrification of homes and cars, then mass scale production should be at the forefront of the government's plans. we should have a lot more homegrown electricity. And they've recently shut down the coal power plant, which was heralded as a really good thing for emissions. Absolutely. But at the same time, we're being told that there's limitations on the supply of electricity, that a lot of people aren't allowed to have higher than an 80 amp fuse fitted to their house because of the problems with supply. It doesn't seem like there's some holistic thinking.
Your tax is not what you should be thinking about anyway. So if you get rid of your gas, you'll get rid of the standing charge, which is about 150 quid alone. That's not what we need to think about. It's more the spark gap, the difference between the gas and electricity price, not the tax on it. We're seeing it already. We're seeing it with some of the suppliers with smarter tariffs, EDF, Octopus, etc., that are doing smarter tariffs for heat pumps. When we start using these to factor in, then that's going to drive the running costs down, and that will drive the market more than any taxation will.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. So Robin, you've been through the process now. What advice would you give to homeowners to ensure that their transition from a fossil fuel boiler to a heat pump is as seamless as possible?
Ultimately, good insulation is good for overall home efficiency. So if that's something that can be looked at or needs to be improved, anyway, that would be, even if you're not transitioning from your boiler, good insulation is going to be better.
The recent changes to the boiler upgrade scheme requirements said that you no longer have to have on your EPC that you've got. It doesn't matter if it says that it's a recommendation to have loft and cavity insulation. That doesn't mean it's not a good idea. If you haven't got loft insulation, in the same way that you wouldn't go out in winter with a heater but without a woolly hat on, it's much easier to insulate a house than it is to heat it, and it's much, much cheaper. Fabric first is a phrase that gets bandied about a lot. Yes, to a point, go for the easy wins. In the same way that if you've got single glazing, you should probably save up and get double glazing before you're thinking about a heat pump or even a new boiler. Fix the leaks before you start putting power into it.
I think consumers need to kind of hopefully educate themselves on what energy actually means as well. It's all you're trying to do is just replace the energy that is lost through your building. I mean, if you put a too big jumper on or a too big coat on for what is going on, you get too hot and you start to got to take layers off. That's what modulation control is basically doing to your building. It's trying to match the heat loss of every second of that day to go. If people can understand that you could have a very efficient heating system running at 21 degrees flow temperature in your heat pump to achieve 21 degrees flow temperature in your house, that's technical, as long as you've got enough volume. So all these people saying, oh, well, the radiators aren't warm or the floor's not warm, you've got to get this across to people. Yes, but are you cold? And if people come back and say, no, I'm not, you say, well, it's doing its job then, isn't it?
It is a tough one because people are conditioned to know if the heating's working by going and touching a radiator and it being hot. Whereas quite often with weather compensation heat pumps that we're fitting, the radiator is colder than your hand. It's colder than body temperature. So you go there and it literally feels cold, and instantly, and I'm guilty of it as well, I've done it at home recently, touching the radiator, it's colder than my hand. Oh, is it working? I'll go and check that it is working.
Yeah, it's because you're 37 degrees and it's you want your room at 21, don't you? That's exactly that. It is a big educational thing, and I don't think there's enough public education on this, whether it's through TV adverts or whatever it is like that. We're so stuck in our ways of, coming home from a meal out for an evening or something like that and getting in and sticking the heating on for half an hour. Those days have got to be gone.
We've been conditioned to react to heat in our houses. We wait until we're cold and then we look for comfort rather than just being comfortable. You wait until you're cold and you go to the thermostat. You wait until you're too hot, then you go to the thermostat. We're never comfortable in our own homes.
I've tried to bring this up for many, many years. When condensing boilers were mandated in 2005, and we're still got on-off controls that are being sold on the market. I mean, I just don't understand. I don't understand that can even be allowed. With a heat pump, the last thing you want is on-off controlling.
Imagine how easy our jobs would be if we'd just done it right 20 years ago. If we'd done it right, the customer would be ready for weather compensating. It would already be designed for 55. It would just be boxes we're moving.
I remember there was a policy that came out about 7 years ago, and I can't remember the name of it, boiler optimization, something, can't remember. And I went and spoke to Bays about it before it launched, and I said, if you're going to have smart controls in there, they need to be modulating controls. Anything else just isn't smart. And lo and behold, when it came out, and probably because of lobbyists for certain manufacturers and large entity companies that I'm not going to name, there were lots of smart controls, and smart meant can be on the internet, but it was still an on-off controller that was about as smart as something from the 30s.
I would say to consumers, if you want some low-hanging fruit, go and get in contact with your installers that you've got now and see if your system is suitable to have a proper modulation control on it. It's to be the best couple of £100 you've ever spent, and you're going to pay itself back quite quickly.
Usually it's the manufacturer's proprietary controller. So for almost all platforms, if it's their own plug-in controller, it usually will make it modulate either on room optimization or weather compensation.
It's a great point, actually, because we're seeing this more and more on the forums. There's people that have just literally put a heat pump in and they're still running it like a boiler. So there's one chap in particular who's basically, he obviously works in an office, so he leaves, he turns his heat pump off, he drives, goes wherever it is that he goes to work, and an hour before he comes home, he goes on the app, turns it back on, and he claims that he's saving about 2 kilowatt hours a day by doing that. But, then you are almost sacrificing the comfort. I find that very strange because it should be running all the time. So what is it that you typically recommend to people, Barry, when, if they are going to come to you and say, look, I'm going to turn it off when I go to the office? Do you have an honest conversation with them, quite frank, and say to them, look, you've got to keep
the
running.
controls off them. Not their heat pump, it's mine. Stop thinking on off, start thinking low and high. Just bring it down a little bit. He might think he's saving 2 kilowatt hours, but if he just modulated it better, maybe dropped the curve at 3 or 4 points, and then you might find he's saved more.
High and low is perfect. That's the right way of saying it. Putting it on a nice setback when it should be the off, so that you've got that the thermal mass hasn't been degraded, and you can bring it back up from not too far, so you're not having to have those huge peaks and troughs. It can still be seen as like a comfort and a setback or an on and an off. But you don't want your system to get cold. If you're out of the house and your house gets cold and your radiators get cold, you're going to have to inject loads more energy to bring it up from that cold point rather than letting it trickle along. And the algorithms in smart boilers and most heat pumps now, that's part of it. You have to really engineer it out. If that's what the engineer or the homeowner's doing, you should really just be following whatever the protocol is that the appliance wants. Those manufacturers are pretty smart, and in most cases they've already thought about it.
Think of a system as, you've got it up to temperature. You're using very, very little energy to just keep it simmering along. You imagine like a very heavy truck on the big motorway that's in heavy traffic and it's doing stop, start all the time. It's using gallons and gallons of fuel that it doesn't need, as opposed to if it was just sitting there at a steady 50, 60 miles an hour just cruising along. It's maximised all its efficiency. And I think that's how we've got to start looking at heating systems as to how they run.
One of the things that quite often comes up is people being alarmed that it's always on. If it's always on, it's going to be costing a lot to run. Well, your fridge is always on as well, and it will just be monitoring it and looking for the amount of energy that it needs to put in to maintain that middle ground. And a heat pump is exactly the same. It should be using its internal algorithms and settings to make sure that it's using the minimum amount of energy to keep your house warm.
And would we say then as a panel that pretty much all of the manufacturers out there of heat pumps, look, nothing's all equal, but they're all pretty good at the end of the day, aren't they?
That's what's came out Open Energy Monitor, is a scatter of different manufacturers. It kind of boils down, it's not the manufacturer that makes a heat pump good, it's the design and installer.
So thank you to our incredible panel today, Robin, Barry, Patrick and Rob, for sharing their expertise today, and to all of our listeners for tuning in. A special thanks to Good Energy for sponsoring this episode. Good Energy has been at the forefront of renewable energy solutions, helping homeowners make sustainable choices that benefit both their wallets and the planet. But before you go, please give us a thumbs up, hit the subscribe button below, stay warm, stay green, stay tuned. Goodbye.